All right, we get to take a look at some more trig functions today. So our goal today is to introduce sine and cosine to go along with tangent that we already know. So just to remind you, tangent is equal to opposite over adjacent. And we're talking about a right triangle. And again, it kind of depends on where you're standing at the triangle, which side is opposite or adjacent. So let's assume for a moment that we're standing down here at this angle. And if so, this side over here is going to be the opposite, and the side down at the bottom is going to be the adjacent. We know that because the side that is not touching the right angle is always the hypotenuse. Well, right now, we have the skills that if we know the angle and we know the opposite, we can find the adjacent. Or if we know the adjacent, we can find the opposite. But we don't know anything concerning the hypotenuse yet. So, we're going to bring into play the same kind of a tool as tangent, but there's two more. And that's sine and cosine. Okay? Sine equals opposite over hypotenuse, and cosine equals adjacent over hypotenuse. Now, a good majority of the time, people that are teaching this are telling people to remember the word SOHCAHTOA. And you probably hear me say that now and then as just a way to try to remember this. And what we're doing is we're saying SOHCAHTOA. And all it does is tell you that sine, so that's the S right here, equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. That's just an easy way to be able to remember those. So, if I was to put some numbers in here, let's put the numbers 3, 4, and 5. And we'll make sure we call that theta, just a Greek letter. So, 3, 4, or 5. So that means that we could say the tangent of theta would be, opposite over adjacent would be 3/4. So we could say tangent theta equals 3/4. The cosine, the sine of theta would be opposite over hypotenuse, so that would be 3/5. And the cosine of theta would be equal to 4/5. All right, so again, these other two tools, sine and cosine, are used exactly like tangent. So let's do a problem just so that you can get a good feel for it. So let's say, now you get to see my great artwork here. Let's say we got a little airplane here. Okay, there's my awesome airplane. And it can see land way down here. We'll do a little lighthouse. Okay, that's my lighthouse. Yeah, it's not going to get better than that. And it wants to be able to calculate how far that lighthouse is away from it right now. Now, it has all kinds of instruments and stuff, but none of the instruments will tell it that distance right there. But what the instruments will tell it is if it drops straight down and over, it'll tell it this distance down at the bottom. And so it's ground distance, it's called. So let's say that it was 26 miles away. And we also know its altitude, so we could find that too. But for a minute, we're not going to do that. And it's looking at an angle. Now, most of the time when we're doing a problem like this, it's going to say the angle of depression. So I'm just going to, for a moment, define that. Angle of depression would be how far down from straight ahead. So if I said angle of depression of 30 degrees, then we would know that this other angle right here is 60 degrees. Okay, that's just a little extra thing. That doesn't have to do with sine cosine for a moment. So we have a 60-degree angle there. We know that the side down at the bottom is 26, and we're looking for this distance right here. So let's label everything. First off, 60 degrees, okay, that's our theta. The 26, let's see, would that be opposite, adjacent? Let's see, this would be the opposite side, and x, of course, is the hypotenuse. Okay, so we've labeled everything. That's one of the most important steps. Now we can actually write our equation. So which equation do we got to use? Depends on what information we have and what information we want. The information we have is the opposite. The information we want is the hypotenuse. So let's see, opposite and hypotenuse together. So we go back real quick. Ooh, let's see which one it was. Opposite hypotenuse. Oh, is sine. So I'm going to use sine, and then I'm going to put the angle, 60 degrees. That tells us kind of where we're standing or where we're looking from. Equals, okay, sine was opposite over hypotenuse, so that would be 26 over x. Now, I know I showed this to you one time before, that when we have an x on the bottom, what we're basically doing is we're multiplying both sides by x, and then we're dividing both sides by sine 60. That's what we're going to be doing. But it's basically the same thing as just swapping sides with these things. But please understand, we're multiplying both sides by x and dividing both sides by sine 60. So we're going to end up with x equals 26 over sine 60. Now, that we've done all the hard stuff at this point. All we got to do now is grab our calculator and punch this in. So that's what I'm going to do. Okay, I'm going to go 26 divided by the sine of 60, and make sure you know how to use your calculator because some of them are backwards. And it'll come out, in this case it comes out to x equals 30.02. Okay, and I'm rounding to 2 decimal places because I want it to be accurate. So the distance from the actual plane to the lighthouse is 30.02 miles. And that's how this all works. And like I said, if you should have recognized that using sine was just like using cosine, except now we're talking about 2 different sides of the triangle. All right, we're going to be doing a lot of this in class, including some more application and everything, and you'll get a pretty good feel for it. Okay, we'll see you in class.